This is the experiment number 2, where we have to measure the VSWR, then impedance, frequency and guide wavelength of a horn antenna. So initially you will be given the setup like this. So what you need to do, the very first step is turn on the source generator. In this, keep the RF level maximum, then frequency you set it at 9 gigahertz. After setting at 9 gigahertz, ensure that it is in amplitude modulation and this RF should be on. Okay, it should be on. So these are the first initial setups what you need to see. Then after this, here in this, you have to keep the tunable short over here. So after connecting the tunable short, which is of this type, so you have to come to the oscilloscope. So in the oscilloscope, you have to keep this part, the moving thing, on the rightmost side. So slowly you move this one by turning this one, and in this output thing, no, you have to see. Okay, see, at this point we got a full minimum voltage, like a straight line. Stop moving this at this point. Come to this scale. In the scale you have to note the main scale reading. Here we got around 8.7, and the 1 year scale you have to take the reading like 5 for an example, whichever is the most coinciding. So 8.85. This is called distance D1, which is the first minima. Then remember always to move in only one direction. Don't come this side, and we are not supposed to go in this opposite direction again. Go only in one direction. Okay, then after this, in the same way I'll go much left side now. As I go, I'll be noting down the next maxima. See, here voltage is getting increased. Okay, at this point I got a maxima. So here this is like 10 point some value. Okay, this is my first maxima, and I'll be writing this as D2. Okay, then and so on again in the same direction I'll move, and I have to get a straight line. This is my next minima. So same way, come here, I got it like 11.1 with some coinciding reading. You have to take it. So when you take this is the distance D3, which is the second minima. So again move, and you'll be getting a next maxima value. So based on doing this, you'll be getting a set of data like this. So what we need to know is, you need to get consecutive distance of maxima and consecutive distance of minimas. Okay, so based on this, you have to take the difference of any two consecutive minimas and any two consecutive maximas, and you have to verify like if both are same. If both are almost same, then your answer is correct. Then substitute in lambda g, which is 2 times of the difference of two consecutive minimas or maximas. You should get the same value over here in the difference. Multiply with 2, you will get lambda g. This is wavelength of guide. So then lambda c is given 2 times a is a fixed value, it's given in the procedure. So from this you will get this value. Then from this you substitute in the formula and calculate lambda naught. After calculating lambda naught, you have to come to f naught, operating frequency. You'll be getting the practical operating frequency, whereas theoretically in the starting of the experiment we had kept at 9 gigahertz, but by doing the experiment we got it as 8.77 gigahertz. So next, replace this tunable short with the help of an horn antenna. Next, after connecting the horn antenna, in this same way you come to the most right side, and then you start moving towards the source. By moving, you observe here in the output, you will be getting a maximum output voltage, maximum VPP at some particular point. So at that particular point you have to stop and count. You can move the position on top. So the VPP is like around 2, then okay, here 23 is there, 23 divisions approx, into then 10 millivolts. So when you multiply that, you'll be getting a V max, voltage max. Okay, that one you have to write it as V max. Okay, you'll be getting it in millivolt. See, in millivolt. You have connected it to channel 2, so in millivolt. In the same way, come to some other position. As you move, now we are worried about only voltage first initially. Okay, move. You have to see some at point. You'll be getting a minimum VPP value. So here is the minimum value. So again here we are getting less. I'll move the position down. See here we are getting the number of divisions are less compared to the previous thing. So here it's like 17 divisions approx into this 10 millivolt. So this is our V min of the horn antenna. So V min we have got. So then what you have to do is, for calculation of VSWR, V max upon V min, you should get like 1.2 or 1.3. But ideally it should be 1. But practically you should get close to 1, like 1.2 or 1.3. If you're getting more values, it's wrong. Then after this, so now we have to come back to the position where we got our Vmax, one particular position. So okay, we got a Vmax over here. So this is our Vmax reading, and let's say at this location you take the distance, the X value you take. What is the coinciding point, like 8.9, that one. So a small mistake. So now it's not a maximum, take the minimum position. So you come to the minimum position. Okay, here is the minima. So in the minima you take the reading of this coinciding point, like here it's like 10.4 something. So this one you have to note it as a reading called X, which is the position of minima for the horn antenna. Okay, then what you have to do, once you move towards the load, then once you move towards the generator and find the very consecutive minima. So now I'll just move on the right hand side. So we have to get a very next minima, consecutive. Okay, so yeah, on moving on the right hand side, we got a minima somewhere around 7.6. This is the minima from one point X. This point is noted as X1 towards the load, we'll assume. Then similarly come to the same point 10.4, which we took as a reference. So 10.4. So this is the original minima which we took as a reference. So again now we'll move towards the source. So as we move towards the source, we'll be getting one more minima, the consecutive minima. Okay, so that distance we got around now 12.6. okay, so with this you have to note it as X2. okay, and just subtract this value with this value and this value with this value, put a mod. So which is the smallest value? Here we got two values. So the smallest value you take, and with that you have to calculate the delta D. Okay, lambda G we have got previously, lambda G over here. Okay, now when you get the difference value, just substitute here delta D, you substitute here, you'll be getting the distance of load impedance towards the source or towards the load. You have to mention it, okay, based on which is the smallest value. Then in the Z0, this is the formula. Lambda naught is the value you have calculated over here, lambda naught. Then lambda C is a fixed value which is 4.56 centimeter. Substitute that, you'll be getting the characteristic impedance in normalized form. Okay, then based on a Smith chart, by plotting the VSWR, and if it is towards, now we had got in this experiment towards, which one bro? Since we got towards the source, we have plotted the graph accordingly, and then based on the point of intersection here, we have written the real part and imaginary part, and with this value we have calculated the value of Z0, which is actual. Basically we denormalize the value. So that's it as the experiment. So we got VSWR, lambda G, operating frequency. Practically in the start time we kept 9, but on performing the experiment we got like 8.77. Then from the Smith chart you have to get this, and you have to mention whether it is towards the load or towards the source. That's it as the experiment.